What makes for a good job, a good marriage, or a good life? In this first module, we'll see how psychologists approach these questions with a scientific frame of mind. Psychology is a rigorous discipline that tests assumptions, bringing scientific data to bear on the questions of central interest to human beings. Psychologists conduct research and rely on that research to provide evidence for their conclusions. They examine the available evidence about some aspect of mind and behavior, evaluate how strongly the data support their hunches, analyze disconfirming evidence, and carefully consider whether they have explored all possible factors and explanations. At the core of this scientific approach are four attitudes: critical thinking, curiosity, skepticism, and objectivity. Like all scientists, psychologists are critical thinkers. Critical thinking is the process of thinking deeply and actively, asking questions, and evaluating the evidence. Critical thinkers question and test what some people say are facts. They examine research to see how soundly it supports an idea. Critical thinking reduces the likelihood that conclusions will be based on unreliable personal beliefs, opinions, and emotions. Scientists are also curious. The scientist notices things in the world and wants to know what it is and why it is that way. Science involves asking questions, even very big questions, such as where did the earth come from? And how does love between two people endure for 50 years? Thinking like a psychologist means opening your mind and imagination to wondering why things are the way they are. In addition, scientists are skeptical. Skeptical people challenge whether a supposed fact is really true. Being skeptical can mean questioning what everybody supposedly knows. Psychology is different from common sense because psychologists are skeptical of commonsensical explanations. Lastly, practicing science also means being objective. Being objective involves trying to see things the way they really are, and not just as the observer would like them to be. Scientific knowledge ultimately is based on objective evidence. To gather objective evidence, scientists rely on empirical methods. An empirical method involves gaining knowledge through the observance of events, the collection of data, and logical reasoning. For scientists, objectivity means waiting to see what the evidence tells them rather than going along with their hunches. Once you start to think like a psychologist, you might notice that the world starts to look like a different place. Easy answers and simple assumptions simply will not do. This is why researchers often say that a study supports a particular prediction, but rarely ever say that it proves anything. So debate and controversy are a natural part of thinking like a psychologist. Psychology has advanced as a field because psychologists do not always agree with one another about why mind and behavior work the way they do. Psychologists have reached a more accurate understanding of human behavior because psychology fosters controversies and because psychologists think deeply and reflectively and examine the evidence on all sides. To understand why others act as they do, most of us trust our common sense, our gut intuitions about how the social world works. This reliance is tempting because children and adults alike tend to regard psychology as easier and more self-evident than physics, chemistry, biology, and most other sciences. Yet, as we've already discovered, our intuitive understanding of ourselves and the world is frequently mistaken. In fact, as the quiz you took at the start of this course showed us, sometimes our commonsensical understanding of psychology isn't merely incorrect, but entirely backward. There are some problems with relying on common sense. Basing knowledge of psychology on previous experiences allows subjectivity to color the understanding of behavior. This subjectivity can be avoided by relying on empirical studies. A particular problem with common sense explanations of behavior is that they are made after the fact, when anything is much easier to explain. through the "I knew it all along" phenomenon. One of psychology's goals is prediction, which must take place beforehand. After the fact explanations are seductive, however, because they make sense and seem accurate. It is the job of research psychologists to determine whether or not such explanations are valid. Then, if they are valid, under what conditions are they useful in providing explanations? Another problem with common sense explanations is that multiple explanations may exist, and they are often contradictory. For example, consider birds of a feather flock together and opposites attract. Now, both of these common sense sayings claim to explain why certain people are attracted to each other. The obvious problem is that one or the other can be used to explain any possible situation. One explains why similar people form friendships, and one explains why different people form friendships. Other sets of common sense sayings also are contradictory. Consider absence makes the heart grow fonder, and its counterpart, out of sight, out of mind. Or better safe than sorry, and its opposite, nothing ventured, nothing gained. We need to avoid black and white or either or thinking, because the truth often tends to fall somewhere in the middle. Now, that's not to say that our common sense is always wrong. Our intuition does come in handy in many situations, and sometimes starts to guide us to the truth. Common sense can also be a helpful guide for generating hypotheses that scientists can later test in rigorous investigations. Formally defined, psychology is the scientific study of behavior and mental processes. As you consider the general definition of psychology, you might be thinking, okay, where's the couch? Where's the mental illness? Now, psychology certainly includes the study of therapy and psychological disorders, but it is much more than that. The study of psychological disorders is a very important aspect of psychology, but it represents only one part of the science of psychology. Some psychologists argue that the field has focused too much on the negative aspects of humanity and neglected topics that reflect the best of human life. Others insist that human weaknesses are the most important aspects of life to study. The fact is that to be a truly general science of human behavior, psychology must address all sides of human experience. This lecture will follow the general outline provided by the text and first cover the four major research perspectives used by psychologists, and then move on to the research methods used by psychologists, and finally we'll take a look at how to understand the results of research. All right, let's start by taking a look at the four major research perspectives, which can be divided into two areas. Perspectives emphasizing internal factors, which are the biological and cognitive perspectives, and the perspectives emphasizing external factors, which are the behavioral and sociocultural perspectives. I've reproduced this table from the text, which gives a nice overview and summary of each of the perspectives, starting with the biological approach, which explores how our physiology, especially the brain and nervous system, produces our behavior and mental processes, and how genetics and evolution have impacted our physiology. The cognitive approach looks at how our mental processes, such as perception, memory, and problem solving, work, and how they impact our behavior. Moving on to the two approaches which look at external factors, the behavioral perspective considers how external environmental events condition our observable behavior, and we'll look really closely at this perspective when we study learning in a later module. And finally, the sociocultural perspective considers how other people and the cultural context impact our behavior and mental processes. Now, you may be asking yourself, which perspective is best? No perspective is better than the others. All perspectives are complementary. They fit together like pieces of a puzzle. Psychologists use all four perspectives to get a more complete explanation of behavior and mental processing. Let's take a closer look at each of these perspectives. Some psychologists examine behavior and mental processes through the biological approach, which is a focus on the body, especially the brain and nervous system. For example, researchers might investigate the way your heart races when you are afraid, or how your hands sweat when you tell a lie. Although a number of physiological systems may be involved in thoughts and feelings, perhaps the largest contribution to physiological psychology has come through the emergence of neuroscience. Neuroscience is the scientific study of the structure, function, development, genetics, and biochemistry of the nervous system. Neuroscience emphasizes that the brain and nervous system are central to understanding behavior, thought, and emotion. Neuroscientists believe that thoughts and emotions have a physical basis in the brain. Electrical impulses zoom throughout the brain's cells, releasing chemicals that enable us to think, feel, and behave. Our remarkable human capabilities would not be possible without the brain and nervous system, which constitute the most complex, intricate, and elegant system imaginable. Although biological approaches might sometimes seem to reduce complex human experience to simple physical structures, developments in neuroscience have allowed psychologists to understand the brain as an amazingly complex organ. According to cognitive psychologists, the brain not only houses neurons and neurotransmitters and various brain structures, but your brain houses a mind whose mental processes allow you to remember, make decisions, plan, set goals, and be creative. The cognitive approach, then, emphasizes the mental processes involved in knowing, how we direct our attention, perceive, remember, think, and solve problems. For example, cognitive psychologists want to know how we solve math problems, why we remember some things for only a short time but others for a lifetime, and how we can use our imaginations to plan for the future. Cognitive psychologists view the mind as an active and aware problem-solving system. And now this view is in contrast with the behavioral outlook, which we'll look at next. The behavioral perspective portrays behavior as controlled by external environmental forces. In the cognitive perspective, an individual's mental processes are in control of behavior through memories, perceptions, images, and thinking. Shifting to the perspectives which focus or emphasize external factors, the behavioral perspective emphasizes the scientific study of observable behavioral responses and their environmental determinants. It focuses on an organism's visible interactions with the environment, that is, behaviors and not thoughts or feelings. It claims that behavior is the result of past history of conditioning within the environment. And it involves two major types of conditioning, classical and operant. Classical conditioning, first described by Ivan Pavlov, a Russian physiologist, involves placing a neutral signal before a reflex. It focuses on involuntary automatic behaviors. The classical conditioning process involves pairing a previously neutral stimulus, such as the sound of a bell, with an unconditioned stimulus, the taste of food. Operant conditioning, first described by B.F. Skinner, an American psychologist, involves applying reinforcement or punishment after a behavior, and it focuses on strengthening or weakening voluntary behaviors. Skinner emphasized that psychology should be about what people do, their actions and behaviors, and should not concern itself with things that cannot be seen, such as thoughts, feelings, and goals. He believed that rewards and punishments determine our behavior. For example, a child might behave in a well-mannered fashion because her parents have rewarded this behavior. We do the things we do, say behaviorists, because of the environmental conditions that we have experienced and continue to experience. The sociocultural approach examines the influences of social and cultural environments on behavior. Socioculturalists argue that understanding a person's behavior requires knowing about the cultural context in which the behavior occurs. This sociocultural approach often includes cross-cultural research, meaning that research compares individuals in various cultures to see how they differ on important psychological attributes. Cross-cultural research is important for testing the assumption that findings for one culture also generalize to other cultural contexts, and as such, it allows psychologists to test for the possibility that some characteristics are universal. The sociocultural context focuses not only on comparisons of behavior across countries, but also on the behavior of individuals from different ethnic and cultural groups within a country. In light of rising cultural diversity in the United States in recent years, there has been increasing interest in the behavior of African Americans, Latinos, and Asian Americans, especially in terms of the factors that have restricted or enhanced their ability to adapt and cope with living in a predominantly non-Latino white society. We're moving on to the next section of the lecture outline, which involves research methods used by psychologists. Some of them are descriptive methods, correlational studies, and experimental research. Just as the name suggests, descriptive research is about describing some phenomenon, determining its basic dimensions, and defining what this thing is, how often it occurs, and so on. By itself, descriptive research cannot prove what causes some phenomenon, but it can reveal important information about people's behaviors and attitudes. Correlational studies tell us about the relationship between variables, and its purpose is to examine whether and how two variables change together. That is, correlational research looks at a co-relationship. For instance, if one of the variables increases, what happens to the other one? When two variables change together, we can predict one from the other, and we say that the variables are correlated. To determine whether a causal relationship exists between variables, researchers must use experimental methods. An experiment is a carefully regulated procedure in which the researcher manipulates one or more variables that are believed to influence some other variable. Psychologists need to be aware that bias may be involved in some of their research studies and how they set up the studies and the methodology and even how they interpret the results. Some types of bias include hindsight bias, which we mentioned. It's also known as the I knew it all along effect, and it refers to our tendency to overestimate how well we could have successfully forecasted known outcomes. As the old saying goes, hindsight is always 20/20. Following the terrorist attacks of September 11th, 2001, many pundits and politicians engaged in Monday morning quarterbacking regarding what could or should have been done to prevent these attacks. Better airport security, better covert intelligence, better warnings to the public, and better prosecution of known terrorists. There may well have been some truth to each of these after-the-fact recommendations, but they miss a crucial point. Once an event has occurred, it's awfully easy in retrospect to predict it, and then suggest ways in which we could have prevented it. As Nobel Prize-winning physicist Niels Bohr joked, prediction is difficult, especially for the future. Related to hindsight bias is overconfidence, our tendency to overestimate our ability to make correct predictions. Across a variety of tasks, most of us are more confident in our predictive abilities than we should be. We're overconfident in many domains of our lives. A national survey of nearly 1 million high school seniors revealed that 100%, yes, all of them, believed that they were above average in their ability to get along with others. 25% believed that they were in the top 1%. A college survey of professors revealed that 94% believed that they were better scholars than their colleagues. Obviously, we can't all be above average, but most of us think we are. Finally, confirmation bias. It's a tendency to seek out evidence that supports our beliefs and deny, dismiss, or distort evidence that contradicts them. We can sum up confirmation bias in this phrase: seek and you shall find. If you're looking for it, you're going to find it, and you're going to ignore disconfirming evidence. Getting back to the research methods used by psychologists, there are three types of descriptive methods: observational techniques, case studies, and survey research. And we're going to focus now on observational techniques. Observational techniques can be structured or unstructured. Controlled observations are likely to be carried out in a psychological laboratory. Rather than writing a detailed description of all behavior observed, it's often easier to code behavior. The researcher simply classifies the behavior they observe into distinct categories. This coding might involve numbers or letters to describe a particular behavior. The categories on the schedule are coded so that the data collected can be easily counted and then turned into statistics. Naturalistic observation involves the studying of spontaneous behavior of participants in their natural surroundings. The researcher simply records what they see in whatever way that they can. Now, compared to the controlled structured methods, it's like the difference between studying wild animals in a zoo and studying them in their natural habitat. And with regard to human subjects, Margaret Mead used this method to research the way of life of differing tribes living on the islands in the South Pacific. In participant observation, the observer actually participates in ongoing activities and records observations. Participant observation extends beyond naturalistic observation because the observer is a player in the action now. Often the researcher actually takes on the role being studied. For example, living in a commune, or becoming a firefighter, enrolling in flight training school, working in a mental hospital, or passing as a patient, being a cocktail waitress, or even joining a cult. This approach was used by Leon Festinger in a famous study into a religious cult who believed that the end of the world was about to occur. He joined the cult and studied how they reacted when the prophecy did not come true. Another descriptive method is the case study, where an individual is studied in depth over an extended period of time. Now, the results of case studies cannot be generalized simply because there's only one person being studied, and cause and effect statements based on the findings of a case study cannot be made. Case studies do offer useful insights that researchers can test in systematic investigations. For example, in the 1960s, psychiatrist Aaron Beck was conducting psychotherapy with a client who appeared anxious during the sessions. When Beck asked her why she was nervous, she reluctantly admitted that she was afraid that she was boring him. Beck probed more in depth and discovered that she harbored the irrational idea that just about everybody found her boring. From these and other informal observations, Beck pieced together a now influential form of therapy based on the premise that people's emotional distress stems from their deep-seated irrational beliefs. Another descriptive method is survey research, which uses questionnaires and interviews to collect information about the behavior, beliefs, and attitudes of particular groups of people. Although surveys can be a straightforward way to measure psychological variables, constructing them requires great care. For example, surveys can measure only what people think about themselves. If you were answering a survey that asked, "Are you a generous person?" how might your answer compare to that of a friend who is asked to make that same rating about you? One particular problem with surveys and interviews is the tendency of participants to answer questions in a way that will make them look good rather than in a way that communicates what they truly think or feel. This is called social desirability bias. A challenge in survey construction is to carefully word, order, and structure the survey questions so that they don't lead the participants to biased answers. Surveys and interviews can cover a wide range of topics, from religious beliefs to sexual habits to attitudes about gun control. Let's move on from descriptive methods to correlational methods. In a correlational study, two variables are measured to determine if they are related or how well either one predicts the other. And a variable is any factor that can take on more than one value. Correlational research is so named because of the statistical technique, correlation, that is typically used to analyze this type of data. The key feature of a correlational study is that the variables of interest are measured to see how they relate. If we wanted to know whether shy people are happy, we might give the same people two questionnaires, one that measures shyness and another that measures happiness. For each person, we would have two scores, and we would then see whether shyness and happiness relate to each other in a systematic way. In conducting a correlational study, the researcher first gets a representative sample of the relevant population, and next the researcher takes two measurements on the sample. Now, strong correlations give us excellent predictability, but they do not allow us to draw cause and effect conclusions about the relationships between the two variables. Correlation is not causation. To see if the variables such as shyness and happiness are related, the researcher calculates a statistic called the correlation coefficient. This demonstrates the type and the strength of the relationship between the two variables, and it ranges in value from -1 to +1. It uses a plus or minus sign to convey the type of relationship, whether it is positive or negative. And let's look more closely at each of these relationships. A positive correlation indicates a direct relationship between two variables. Low scores on one variable tend to be paired with low scores on the other variable. High scores on one variable tend to be paired with high scores on the other variable. For instance, SAT scores and first-year college GPA tend to be positively correlated. A person's height and weight also tend to be positively correlated. A negative correlation, on the other hand, shows an inverse relationship between two variables. Low scores on one variable tend to be paired with high scores on the other variable. For instance, there is a negative correlation between how much time a student watches TV and his or her grades in school. Mountain elevation level and temperature are also negatively correlated. In understanding the strength of the relationship, it is important to pay attention to the absolute value of the correlation coefficient, which is the second part that ranges from 0 to 1. 0 and absolute values near 0 indicate no relationship. Now, as the absolute value increases toward 1, the strength of the relationship increases. And for example, an R of -0.75 and an R of positive 0.75 show an equally strong relationship. Now, it is important to remember that the sign of the coefficient conveys nothing about the strength of the relationship. It simply refers to whether it is in a positive or negative direction. Scatter plots give us an understanding of the predictability that we can gain from correlational studies. Scatter plots are simply visual depictions of correlational data, and we're going to look at a couple of them. Each data point on the scatter plot is a person's scores on each of the two variables. On the x-axis are scores on one variable, and on the y-axis are scores on the second variable. Correlational studies usually involve a large number of participants, therefore there are usually a large number of data points in a scatter plot, but these scatter plots in this figure are merely examples to show you what they look like. Now, in A and B, the data points line up in a straight line, and this indicates maximal predictability, showing increasing trends or a perfect positive correlation in A and a perfect negative correlation in B, or decreasing trends. Now, when we look at C, we notice the data points are just scattered all over the place in a random fashion. This indicates no relationship between the variables, with minimal or no predictability. Even if we know the value of variable x, we really can't predict with much certainty the value of variable y. Now, as we look at the bottom two graphs, D and E, we see that the data points aren't perfectly aligned, but we do notice that there seems to be something going on here. In D and E, there seems to be a fairly strong relationship because there's not a lot of scatter. And this indicates correlations with strengths between -1 and +1. Now, as the amount of scatter of the data points increases, the strength of the correlation decreases. This may help you to better see how the value of the correlation coefficient relates to what the scatter plot looks like as we move from a +1 to a -1. Correlational research can lead to what is known as the third variable problem. This is where a variable that has not been measured actually accounts for the relationship between two other variables. Third variables are also known as confounds. Correlation indicates there is a relationship between two variables, but causation cannot be concluded. To understand this, consider this example. A researcher measures two variables, the number of ice cream cones sold in a town and the number of violent crimes that occur in that town throughout the year. The researcher finds that ice cream cone sales and violent crimes are positively correlated. This rather high correlation that was found would indicate that as ice cream cone sales increase, so does violent crime. Now, would it be reasonable for the local newspaper to run the headline, "Ice cream consumption leads to violence"? And should concerned citizens gather outside their local ice cream shop to stop this madness? Probably not. Perhaps you have already thought of the third variable that might explain this correlation: heat. Researchers have shown that crime goes up when the temperature rises. And as any ice cream shop manager will tell you, ice cream sales are higher when it is warm outside. If observational methods, case studies, and correlational research don't allow us to draw cause and effect conclusions, what kind of designs do? The answer: experimental designs, often simply known as experiments. These designs differ from other designs in one crucial way. They permit cause and effect inferences. The researcher manipulates one or more independent variables and measures their effect on one or more dependent variables while controlling other potentially relevant variables. When a researcher designs an experiment, the researcher begins with a hypothesis about the cause and effect relationship between two variables. One of the variables is assumed to be the cause, and the other variable is the one to be affected. Researcher control is a key aspect of experimental research. The experimenter controls for the influence of possible third variables and makes sure that they are held constant across all of the experimental groups and conditions. The experimental controls for any possible influence due to individual characteristics of the participants and uses random assignment to equalize participant characteristics across the various groups in the experiment. Random assignment means randomly assigning the participants to groups in an experiment to equalize the participants' characteristics across the various groups in the experiment. So every participant has an equal chance or probability of ending up in a particular group. An important aspect of experimental research is to be sure that variables are operationally defined. This is a description of the operations or procedures that a researcher uses to manipulate or measure a variable. When we define our independent and dependent variables for the purposes of a study, we're providing what is called an operational definition, a working definition of what you're measuring. Specifying how you're measuring the variables of interest is important because different researchers may define the same variable in different ways and end up with different conclusions as a result. Just imagine that two researchers used two different doses of Prozac and measured depression using two different scales. They might end up drawing different conclusions about Prozac's effectiveness because their measures told different stories. Still, operational definitions aren't like dictionary definitions of a word in which just about all dictionaries agree on the right definition. Different researchers can adopt different operational definitions for their studies. However, making sure that your variables are operationally defined facilitates the replication of your experiment, which can strengthen your conclusions. Let's say you have a hypothesis that a particular medication is effective in treating anxiety. The simplest of experiments is one with two groups in which participants are randomly assigned to one of the groups. One of the groups will be exposed to the independent variable, the medication, and the other will not be. Now, we must also be aware of the placebo effect, which can arise not only from a conscious belief in the treatment, but also from subconscious associations. The placebo effect is improvement, resulting from the mere expectation of improvement. Participants who received the drug may have gotten better merely because they knew they were receiving treatment, and this knowledge could have instilled confidence or exerted a calming influence. The placebo effect is a powerful reminder that expectations can create reality. Now, in medication research, researchers typically control for the placebo effect by administering a sugar pill. Now, the placebo effect has an evil twin of sorts, if you will, the nocebo effect. The nocebo effect is harm resulting from the mere expectation of harm. In one study, individuals who were allergic to roses sneezed when presented with fake roses. In another, researchers deceived a group of college students into believing that an electric current being passed into their heads could produce a headache. Now, more than 2/3 of the students reported headaches, even though the current was imaginary. Including a control condition that provides a placebo treatment is extremely important, as is keeping the participants blind to their condition assignment. Still, there's another potential concern with an experiment. In some cases, the participant doesn't know the condition assignment, but the experimenter does. Now, when this happens, a nasty problem can arise, which is an experimenter expectancy effect. It occurs when researchers' hypotheses lead them to unintentionally bias the outcome of the study. This kind of happens because the researcher's bias subtly affects the results, and in some cases the researchers may end up confirming their hypotheses even when those hypotheses are wrong. Now, because of this effect, it's essential that experiments be conducted whenever possible in a double-blind fashion. And this means using a control measure in which neither the experimenter nor the participants know which participants are in the experimental and control groups. By voluntarily shielding themselves from the knowledge of which subjects are in which group, researchers are guarding themselves against confirmation bias. This measure controls for experimenter expectations. If the experimenter knew which condition the participants were in, then she or he might unintentionally treat them differently and thereby impact their behavior. The last section of this lecture covers how to understand research results. Psychologists use two kinds of statistics. The first are descriptive statistics, which are used to describe the data of a research study in a concise fashion. by the use of the mean, median, and mode, and measures of central tendency of a frequency distribution. In addition to descriptive statistics, psychologists use inferential statistics, which allow us to determine how much we can generalize our findings to the general population. And it is through the use of frequency distributions, which indicate the probability that the results of our study are due to random variation rather than the actual results of our study. When trying to understand research results, we need to consider statistical significance. And I'm going to go back to a couple of examples I gave previously in this lecture. Let's consider the experiment where we had a medication to help with anxiety, and we gave it to the experimental group, but did not give it to the control group. And after a couple weeks, we gave an anxiety survey. And let's say we found that there was a lower average score on the anxiety survey in the experimental group compared to the control group. I mean, we found a difference, and it seems to indicate that the medication did something. But to figure out whether the difference we observed in our sample is real, we need to conduct statistical tests to determine whether we can generalize our findings to the broader population. A significant finding is one that has a probability less than 0.05 that it was due to chance. And researchers calculate something called a p-value, which helps you determine the significance of your results. This minimum level, 5 and 100, is taken as the probability that the finding occurred by chance. When the finding would have occurred by chance less than 5 and 100 times, we say that it's statistically significant. A statistically significant result is believable. It's probably a real difference in our sample. Now, a significant finding does not ensure that the result has practical significance or value in our everyday world. To understand this, we need to understand that a major determinant of statistical significance is sample size. The larger the sample size, the greater the odds, all other things being equal, that a result will be statistically significant. With huge sample sizes, virtually all findings, even tiny ones, will be statistically significant. Now let's consider the correlation between shyness and happiness that we talked about earlier. And let's say we found a correlation of 0.06 between shyness and happiness. And we used a sample of 500,000 people. Now this correlation would be statistically significant at the 0.05 level, yet it's so small, it's so minuscule in magnitude that it would essentially be useful, or useless rather, for predicting anything. Measures of central tendency give us a sense of the central score in our data set, or where the group tends to cluster. In turn, there are 3 measures of central tendency. The mean, which is the numerical average for a distribution of scores, the median, the score that is positioned in the middle of the distribution of scores when the scores are listed from lowest to highest, and the mode, which is the most frequently occurring score in a distribution of scores. The mean is the most commonly used measure of central tendency, and it is used to analyze data in many inferential statistical tests. Often the average score on a dependent variable is used to compare groups, the experimental group and the control group. For example, the average score on a anxiety survey or a depression inventory. And the mean can be distorted by extremely high or extremely low scores because it uses all scores in its computation. Let's say we have scores from 1 to 10, and we have an outlier of 50. Now this will pull the mean toward 50, and consequently it will not be a good indication of central tendency. Descriptive statistics also give us measures of variability, which are designed to provide an idea of how scattered a set of scores tends to be. There are 2 measures of variability, the range, which is the difference between the highest and lowest scores in a distribution of scores. Now, like the mean, the range can be greatly distorted by extremely high or extremely low scores. The other measure is standard deviation, which is the average extent to which the scores vary from the mean of the distribution. A larger standard deviation means the scores tend to vary greatly from the mean. A smaller standard deviation means that scores do not vary very much from the mean. The standard deviation is especially relevant to the normal distribution or bell curve, which we'll take a look at. A normal distribution is a symmetrical bell-shaped curve with a majority of the scores falling in the middle of the possible range and a few scores appearing toward the extremes of the range. And you can see this in a frequency distribution. The main aspects of a normal distribution, the mean, median, and mode, are all equal because the normal distribution is symmetric about its center. The percentage of scores falling within a certain number of standard deviations of the mean is set. About 68% of the scores fall within one standard deviation of the mean. About 95% fall within two plus or minus standard deviations of the mean, and more than 99% fall within three standard deviations of the mean. Here's a frequency distribution showing the shape of a normal distribution, which is a bell shape. And it also shows that about 68% of the scores will fall within one standard deviation of the mean. And about 95% of the scores will be within two standard deviations of the mean. And over 99% will be within three standard deviations of the mean. And an interesting characteristic of the normal distribution is that you can calculate a percentile rank through this characteristic of the normal distribution, and a percentile rank is covered more thoroughly in your text. You need to recognize that normal distributions can have different standard deviations. These are normal distributions with the same mean but different standard deviations. Normal distribution A in blue has a smaller standard deviation than normal distribution B in green. As the standard deviation for a normal distribution gets smaller, its bell shape gets narrower and the mean taller. If we don't have a normal distribution, we have what is called a skewed distribution. These are asymmetric frequency distributions in which some unusually high scores distort the mean to be greater than the median. We have right skewed, also called positively skewed distributions, where there are some unusually high scores, but most scores tend to be low. Or we can have a left skewed, also called a negatively skewed distribution, where there are some unusually low scores, but most scores tend to be high. Here are a couple of visual examples of skewed distributions. A right skewed frequency distribution is on top, in which the tail of the distribution goes off to the right. In a right skewed or positively skewed distribution, the mean is greater than the median because the unusually high scores distort it. On the bottom, you'll see an example of a left skewed frequency distribution, or a negatively skewed distribution, in which the tail of the distribution goes off to the left. This mean is now less than the median because unusually low scores distort it. Skewed distributions result in distortions of the mean. Distortion occurs for the means of skewed distributions because unusually high or low scores distort the mean in the direction of the tail of the distribution. Also, with a skewed distribution, the median should be used as the measure of central tendency because atypical scores in the distribution do not distort the median. I know we've covered a lot of material in this lecture, and there is a reason for that. I want you to appreciate psychology as a science. There is a scientific mindset emphasizing systematic methods of collecting and analyzing data and drawing conclusions. There is an empirical approach. The concepts in this first module are important to understand, and we will be building on these concepts in subsequent modules. Now, there are plenty of great reasons to learn more about psychology, even if you don't plan to become a psychology major or work in a psychology-related profession. Psychology is simply all around you and touches on every aspect of your life. Psychology can help you better understand yourself, and you'll gain a stronger grasp of research methods. It can give you a better understanding of the people around you. You'll develop your critical thinking skills, and it can also give you greater insight into mental illness.